This video is a this video is a Follow Me video for Session 11, Module M4. Module M4 is a module about summing and counting where you iterate through a sequence, so adding up values in a sequence, for example. But it also says some things about testing, and that's what this Follow Me video is about. To do too says to watch this video, so you're watching it now. Good. Now, in testing, which is what we're talking about now, in testing there are lots of different ways to test things. In all cases, in our form of testing, what's called unit testing, we calculate an expected answer for the code that we're going to test, and then we run the code that we're going to test and see what answer it gives. So in all these tests, we're going to be testing a function called SumSequence. Now you will later write the code for SumSequence, but what it's supposed to do, so it's down here, is SumSequence takes in a sequence of numbers and is to return the sum of the numbers in that sequence. So for example, if the sequence were that, it should add up those numbers and return 23. That's the function that we're testing. Right now, no code for it, so it will currently fail tests. Just to illustrate that, I'll go ahead and run it here, and you can see that here's the expected value, but the actual is none because we haven't implemented the function yet. Now, continuing with our discussion of testing here, the first of the kinds of tests being demonstrated here are using what's called an oracle. An oracle means that you use some outside source to compute the correct value for what the function is computing. So for example, here are some numbers. Even without me adding them up, I can use the built-in sum function. Turns out there's a function built into Python that computes the sum of any sequence you give it. So this oracle answer is whatever these things add up to according to Python. This, from SumSequence, on the same sequence, is what my code gives. And so I can use that as a test. Again, right now, when I run that test, well, apparently Python thinks that the sum of those numbers is that number highlighted there. But of course, I haven't yet written any code, so it is failing that test. Let's go down there and implement some code. Let's see here. So I'm going to go down there and I'm going to put in a, let's see here. Let's go find the, so let's go find the relevant function here. So let's see here. This was testing, so here's all the testing code. And here is the function that we're to implement. Again, it takes a sequence and is to add up the numbers in the sequence. Now I'm going to put a wrong result. So that's certainly not the sum of the numbers in the sequence, or at least not, generally not. So I am failing tests. The expected was that, the actual was that. I could write in some code here that writes a loop and sums through it, and that's what you're going to do. But I'm going to, just to demonstrate things, do what you're not allowed to do. Namely, I'm going to use the built-in sum function on that sequence that is passed in here. So your function is supposed to calculate the sum of the numbers in the sequence. Well, I'm going to use the built-in sum function. Again, you're not allowed to because we want you to write code that explicitly loops through the sequence. But it's fine as a demonstration of testing. So now when I run, I see that the oracle predicted that in my code, which happens to use the oracle, gives the same result. So it's passing tests, and then this third test, let's go up and look at it. This third test generates a random 10,000 numbers using the random rand range function, getting random numbers between -10 and 10 inclusive. And so it adds up, it generates 10,000 of those using code that we'll talk about in our next session. It then says the oracle answer is what the built-in said. This is what my function is saying. Again, we're just testing my function, so the details of how my function works is not critical here. But notice that it is on test 3 passing up that case. Now, that 10,000 random numbers added up to -242 this time. This time, since they are sort of random numbers, it added up to a different number because it was a different sequence of random numbers. More on that at the tail end of this discussion. The next test, test 4, is using the kind of testing you've been doing all along, where you take a known sequence here, 48 minus 10, and you add them up, 38, and that's the known answer that you computed by hand. That's the testing you've been doing all along. Here's a special case of that where the known test case, the one that you know the value for, is the empty list, whose sum of numbers is 0 because there's no numbers in there. Now that's what's called a boundary test, or boundary testing, or edge testing, and that's what's called a edge case or a corner case. Namely, a case of all the possible sequences that we could test, this is the smallest such. It's at the boundary, the edge, the corner of the possibilities of things we could test. You always try to test those cases because those tend to be places where code tends to be wrong, at the corner or edge of the space of possibilities. So this one tested that, and I believe that it passes that test just fine too. And there we are. So 38, 38, 0, 0. So our code is passing tests. Now, let's see here. Here is the next test that we're going to do. This is using what's called probability theory to do some tests using probability theory. Now, this is pretty fancy stuff, so don't worry too much if you don't follow it completely, but the idea is simple enough. If you were to draw to produce a sequence of random numbers, each of which is between -10 and 10 inclusive, and you were to do that lots of times, say 10,000 of them, well, the numbers themselves would on average be 0, so the sum on average should be about 0. That's just common sense, but it also is what's called the law of large numbers, so there's some mathematics behind that. So here that code is doing that. It's generating 10,000 random numbers between -10 and 10 inclusive. Rand range doesn't include the top one, just like range doesn't. And as we've just seen, our intuition is that if we do 10,000 that average each one to 0, the sum is going to be about 0. Now, we can even do better. The central limit theorem from mathematics tells us not only that will it be about 0, but it gives some idea of the range, the variance from that value. And the central limit theorem says that if you do 10,000 random numbers, each one between -10 and 10, about 19 times out of 20, the sum's going to be less than 1,216. 10,000 numbers, each between -10 and 10. So if they were all -10, that would be -100,000. If they were all +10, that would be +100,000. Of course, we wouldn't expect those extremes, but 1,216, in the context of numbers whose sum is between -100,000 and +100,000, is about 0, indeed. So let's see how this goes with our probability theory here. Now, probability theory says that about 19 times out of 20, the result should be less than 1,216. So remember, we had 10,000 random numbers. They in fact added up to -234. That is close to 0 by definition, because it's less than what probability theory predicts will be less than. And so it passed the test. If I run it again, I get a different set of random numbers. And this time I get 213, which is also passing the test. And if I were to do this lots and lots of times, roughly 19 times, oh, there we go. There's one that failed the test. By chance, my third one failed the test. It's beyond, outside of the range. So about 1 in 20 times, I should have that happen. And as long as it's happening only about 1 out of 20, I'm passing the test. I have confidence that my code is correct. Let's see. And then, so that's using probability theory. So we've seen 3 ways of testing. One, all of which are parts of unit testing. One is you use a separate source to come up with the expected answer, like the sum function. That's usually valuable when you're trying a new way to compute the value that maybe is faster or more efficient in some way. You use the old way, the oracle answer, maybe the slower way to compute it, that you know works, to test whether your new way also works. That's using an oracle. And then the kind of testing we've been doing, known cases, you just take that and by hand compute the known value. And then we saw boundary cases, boundary testing, where you look at a test case that is at the edge of the possibilities. And then we did that fancy testing that used probability theory, where to pass a test means that most of the time, the value that is returned is that which probability theory says will come back most of the time if the from the random numbers, and we can compare our numbers, see if they most of the time are near the predicted value, and if so, we're passing the test. Last thing I want to say is random numbers. Computers don't generate random numbers at all. They generate what's called pseudo-random numbers. You can read lots and lots about that at the internet, but the basic idea is simple. You start with a seed. So I'm going to go to seed 42, and it takes that number and it scrambles it in some way. Maybe it multiplies it by 3013, takes the middle 10 bits, the middle part of that number, then multiplies that by some other number, takes some more middle bits, and scrambles it up to come up with a random or apparently random number. And then it takes that apparently random number, and to get the next random number, it repeats the same process on that apparently random number. So pseudo-random numbers that computers generate are not random at all. They're determined by the starting place, the seed. But the particular way it does the scrambling has been carefully chosen by quite sophisticated mathematics so that the sequence of numbers that is generated, the pseudo-random sequence, has properties that real random numbers would have. Their average is what the real one would predict. Their standard deviation is what the real one would, a real random sequence would predict, and so forth. So again, they appear random. They have properties of randomness, but they're not random at all. They're based on the starting point. Now, when I use 42 as the seed, I get a certain set of random numbers that in this example added up to minus 983. When I run it again, I'm using the same seed. So I get the same sequence of random numbers, therefore that same sum. So you use this if you want your results to be reproducible. But if instead you want them to vary from run to run, one common approach is to take the time of day. This takes the time of day and looks at the last three decimal digits of it or something like that. So it takes something that comes from the time of day. And when I run, here at this time of day that just ran, I got a set of random numbers that happens to add up to minus 86. When I run now, which is a slightly different time of day, I get a different set of random numbers, which happens to add up to 144. So this is what you can use to create different results each time, and that's what a simulation would typically use, again, using a fixed seed only for testing purposes to get reproducible results. Well, that's a little bit about testing. When you start this exercise, you can mark to-dos 2 and 3 is done and move right on to to-do 4, where you will implement some sequence. You will write some code here that uses a for loop to go through the sequence and add up the numbers in the sequence. That's your job. You're not allowed to use the built-in sum function for your code, though the code here uses it for testing. If any of that testing stuff isn't clear to you, just ask your instructor to explain again, and just ask your instructor to help you out with understanding it.